In this session, we're going to look at factors and multiples. In the Singapore Mathematics curriculum, this chapter fits into grade 7. Prime numbers is a natural number greater than 1 that has no positive divisors except 1 and itself. For example, 2, 3, 5, 7, 11, 13, 17, 19, 23, etc. are prime numbers. So let us look at 5. 5 divided by itself, 5 equal 1, and that is a whole number. 5 divided by 1 equal 5, which is also a whole number. However, 5 cannot be divided by another number to give us a whole number, so we say that 5 is a prime number. Let's look at 2. 2 is the only even prime. 2 divided by 2 itself equal 1, and 2 divided by 1 equal 2. But 2 cannot be divided by any other number to give you a whole number. So therefore we say that 2 is a prime number. Let's look now at composite numbers. Composite numbers can be written as a product of 2 or more primes. For example here, 4. 4 can be written as 2 times 2. 12 can be written as 6 times 2. 2 is a prime number, but 6 isn't. However, 6 can be written as 2 times 3. So therefore 12 is equals to 2 times 3 times 2. And that is a product of primes. Similarly, you can write 10 as 2 times 5. And of course, both 2 and 5s are prime numbers. Next, I define factors. If 2 times 3 equals 6, we say that 2 and 3 are factors of 6. 1 times 6 equals 6. 1 and 6 are also factors of 6. The multiples here would mean like 2, 4, 6, 8, 10. Now these are the multiples of 2, the 2 times table. 3, 6, 9, 12, 15, etc. are multiples of 3, and this is the 3 times table. And we notice that 6 is the lowest common multiple between 2 and 3. So these are the multiples of 2, and here are the multiples of 3, and the lowest common multiple is 6. Now, here are some examples. The first example wants us to list all the factors of 12. 12 is quite a small number. It's not very big. So we do not need to apply any method to get the factors of 12. We can just list down all the possibilities because 12 is not a big number. For example, we know that 12 is 1 times 12 equal 12. And 2 times 6 is equals to 12, 3 times 4 is equal to 12. So we can easily list out the possibilities of numbers that can be multiplied to give us 12. And we conclude that 1, 2, 3, 12, 6, 4 are factors of 12. And there are 6 factors, out of which only 2 of them are prime numbers, 2 and 3. So the prime factors of 12 are 2 and 3, but 12 itself has 6 factors, including 12 itself. Every number is a factor of itself because 12 divided by itself, 12 equal 1. And 1 here is not a prime number, so it's not a prime factor, but it is a factor. 1 is a factor of every number because every number can be divided by 1 to give you itself. And that is a whole number. Then we look at the second example. It says prime factorization of 12. These two examples are quite different. When they ask for prime factorization of 12, it means that we have to write this number 12 as a product of its prime factors. And you can either use the tree method or the division method to get the answer. So in this case, I put 12 here, and I use the division method. I divide by the lowest prime factor of 12, that is 2. 12 divided by 2 equals 6. I further divide 6 by 2 and to give me 3. Then I realize that 3 cannot be divided by 2 to give me a whole number. So I divide 3 by its lowest prime factor, which is 3. So 3 divided by 3 equal 1. When I see this 1 here, I will be very happy because this is the end of my division process. I reduce 12 to 1 through division process. And once I hit a 1, my division process is complete. But I have to reduce this original number to a 1 by dividing continuously by its prime factors, the lowest prime in fact. So now 12 equal 2 times 2 times 3, which equals to 2 squared multiplied by 3. A composite number can be written as a product of its prime factors, and we call this prime factorization. So again, look at the two examples. One of them says list all the factors of 12. The other says prime factorization of 12. We look at a more complicated example, 96. 96 is quite a big number, and the question wants us to list all the factors of 96. Now, you can do like what you did previously, the previous method, to list all the factors like this. Something times something equals to 12, and you list down all the possibilities. But because 96 is a big number, you will most probably make a mistake or make an omission, error and omission, if you use that listing method. So to find all the factors of 96, we use the prime factorization method again. We write 96 here and use the division method and do prime factorization as normal. So we divide 96 by its lowest prime factor, 2, to give us 48. And we continue the division process until we hit a 3. Then we say that 3 cannot be divided by 2. I need to divide 3 by the lowest prime factor of 3, which is 3. So 3 divided by 3 equal 1. Once I reach 1 here, my division process ends. Then the question says list the factors of 96, not the prime factors, but listing all the factors. And this is quite different. So what I do is I take all these numbers here in black, here, this side, copy them down. They are all factors of 96. And then I turn my attention to this side of the column, write the numbers in red, and I notice that there is a 2 here in the beginning. So I write 2 here. This is a factor of 96. The next factor is 2 times 2 equals 4. The next factor is 2 times 2 times 2 equals 8. The next factor is 2 times 2 times 2 times 2 equals 16. And the next factor is 2 times 2 times 2 times 2 times 2 equals 32. The next factor will be 2 times 2 times 2 times 2 times 2 times 3. And this is 96 itself, equal 96. But I had earlier included 96, so I don't have to include it again. But if you did not include 96 earlier, you will have to include it. And this is all our factors of 96. If you count them, there are 12 of them. And if you look at them, there are only 2 prime factors, 3 and 2. All the other numbers, the other factors, they are not prime factors. They are factors, but they are not prime. And of course, 1 is not a prime number, so it's not a prime factor. Again, you look at here, you get 96 itself. So 96 is a factor of itself. Next, we look at the prime factorization of 96. Now, this prime factorization process, it's the method where you take all these numbers here, the prime factors, and you multiply them. 2, 2, 2, 2, 2, 3. So 2 to the power of 5 multiplied by 3. And this is the prime factorization of 96. Notice how different these two examples are. They are not the same. Next, we look at square and square root, cube and cube root. If I have a number 12 times 12, this is 12 square, and 12 square is equal to 144. The square root of 144 equals 12. So square root is the opposite of square, right? If I square 12, I get 144. If I square root 144, I get 12. It's like moving, it's like, you know, the opposite, moving backwards of the other. Similarly, the cube. 12 times 12 times 12 equals to 12 cube. And this is equals to 1728. But if I take the cube root of 1728, I will get 12. So the cube root is actually like the opposite of the cube, right? You cube a number, and then after that, if you take that number and you cube root it, you will get back the original number, 12. So here is another example of 2 times 3 times 2 times 3 times 2 times 3. All multiplication signs. And what I do is I put brackets on the first set of 2 times 3, I put brackets on the second set of 2 times 3, and I put brackets on the third set of 2 times 3. And I say that there are 2 times 3, the whole thing bracket, cube. There are 3 sets of 2 times 3. So it's 2 times 3 bracket, the whole thing, cube. Over here, it's actually the same example, but it's rearranged differently. Instead of 2 times 3 times 2 times 3 times 2 times 3, I have 2 times 2 times 2 times 3 times 3 times 3. And I say that there is 2 cube, 2 cube multiplied by 3 cube. That's much better. So 3 cube multiplied by 2 cube. And that is 2 times 3 bracket cube. They are the same thing. These two are actually the same. Now let's look at, see if we can have this zoomed in. An example here, 484. The square root of 484. And the question says they want us to find by prime factorization the square root of 484. So prime factorization gives us a hint that we have to either use the tree method or the division method. And I use the division method, so I put 484 here and I try to divide it by the lowest prime factor, which is 2. Right? So 484 divided by 2 is 242, and 242 again I divide by 2 to give me 121, which cannot be divided by 2 any further, so I divide by 11, the lowest prime factor of 121. 121 divided by 11 is 11, and of course 11 being a prime number can only be divided by itself, which is 11. So 11 divided by 11 equals 1. If I see this 1, I know that my division process has ended. So I write 484 as a product of its prime factors. 2 times 2 times 11 times 11. And that would be 2 square multiplied by 11 square. We know from our previous step that this is equal to 2 times 11, the whole thing, square. But the question wants to find the square root of 484. Not 484. Find the square root of 484 by prime factorization. So what I do is, this is 484 here on the left hand side of the equation. So I put a square root sign over the 484. But I must also put a square root over the right hand side of the equation so that the two balances. So I put a square root over 2 times 11 brackets, the whole thing, square. right? So this whole expression here, 2 times 11 square, I put under a square root. So make sure that you do not forget the brackets. Do not ever remove the brackets. And make sure that the 2 here, the square, the teeny little 2 on top, is inside the square root sign. The whole thing under the square root sign. And this will be reduced to 2 times 11. Later on, I have a small example to show you why, to explain this, if you are interested. But typically, if you see this type of example with a square root sign and a square, the square root can be removed. But in order to remove the square root, you have to make sure that the square here includes everything in the bracket, the entire expression. It's not always like that. Sometimes it is not like that. But in this example, it is. The entire expression of 2 multiplied by 11 is put in a bracket, and the square is outside the bracket. This is a multiplication sign. So if we put square root in this way, you can remove the square root. The answer is just 22. The square root of 484 equal 22. Then we look further at another example that wants us to find the cube root of 1000 by prime factorization. So we do prime factorization for 1000, again by the division method, and I divide by 2 to give me 500, and I again divide by 2 to give me 250, again divide 250 by 2 to get 125, and I know that 125 cannot be divided by 2, so I divide by 5, the lowest prime factor. And I do this until I get a 1, and which ends my division process. Then I write 1000 as a product of primes. So 2, 2, 2, 5, 5, 5. 2 times 2 times 2 times 5 times 5 times 5, and this is equal to 2 cubed times 5 cubed. Again, we know that this is 2 times 5, the whole thing, cube. The question wants to find cube root of 1000, not 1000. So we have to write a cube root over 1000 on the left-hand side of the equation. And when we write a cube root on the left-hand side of the equation, we also have to write that cube root on the right-hand side of the equation, which is 2 times 5 bracket cube. So make sure, again, remember to copy back the bracket. Don't omit the bracket. The bracket cannot be removed. And remember that if this is a cube, the cube is under the cube root. And when we see this type of situation, we can remove the cube root, right? Because the cube and the cube root, they cancel out each other in this type of example. So equal to 2 times 5 equal 10. And so we say that the cube root of 1000 equal 10. So let us look at what I was talking about just now here. This was the explanation I was saying that I would give, right? We wrote 1000, a cube root of 1000, and I said that if you apply a cube root on the left hand side, we need to apply cube root on the right hand side. And then here I attempt to explain why, if we see this kind of situation, that we can omit the cube root. So another way of writing the cube root, right, is to put a big bracket over everything you see under the cube root and to the power, erase it to the power of 1/3. So this expression here on the right hand side of this equation is equal to 2 times 5 bracket, the whole thing cube, and then you draw square brackets and raise the entire expression to 1/3 power. Cube root is written as the expression to the power of 1/3. If it's square root, it would be 1 over 2. But this example I gave is cube root, so it's 1 over 3. And this is equal to 2 times 5, because this whole exponential expression here, 3, is actually it's the same as 3 times 1/3. And that equals to 1. Which is why when you see this kind of situation, you can omit the cube root. And your final answer is just 2 times 5. Omit the cube root and remove the cube. That I must say. Right? Don't keep the cube. There is no need to, because it's 3 times 1/3, and that's equals to 1. So actually this concludes my presentation for this part. Thank you for watching.